Hey guys, Jake here coming at you with another math problem today. Here's the problem I'm going to be showing you today, continuing on with some integration by parts. Specifically, we're going to solve the integral, or we're going to find the integral of x to the 3/2 power times ln x dx. So let's jump into it. Like I already said, we're going to be solving this with integration by parts. I've written the integration by parts formula up here at the top in red, so that we have that to refer back to. But really, when you're doing an integration by parts problem, the first thing you want to do is, essentially all you need to do is decide which piece of your integral is going to be u and which piece is going to be dv. This is up for you to figure out which is going to be which. And sometimes there's a little bit of leeway in making that decision. But really what you want to think about is which of your two pieces, so obviously we have these two functions being multiplied together here, which of them is easier to take the derivative of versus integrate, and then which one's easier to integrate versus find the derivative. Because whichever piece you call u, you're then going to have to use its derivative at some point, and whichever piece you call dv, you're going to have to use its antiderivative at some point. So when you look at these two pieces, x to the 3/2, clearly whether we find the derivative or the antiderivative, that's just going to use the power rule. And in either case, we're going to be left with some constant times x to some fractional power. So whether we take the derivative or the antiderivative of this term here, it's not really going to make too big of a difference. But looking at this other term, natural log of x, if we take the derivative of natural log x versus the antiderivative, taking the derivative of natural log x is going to be quite a bit simpler than taking the antiderivative of natural log x, because if we take the derivative of natural log x, that's just going to be 1 over x. This is just a derivative that you would probably want to memorize or put on your formula sheet so you have that to refer back to. But the derivative of natural log x being 1 over x is pretty simple. If we try and find the antiderivative of natural log x, it's going to be quite a bit more complicated. So what that tells us is when we are deciding which piece of this integral we want to call u and which piece we want to call dv, we're probably going to want to call natural log x our u and x to the 3/2 our dv, because taking the derivative of natural log x is going to be a lot easier than finding its antiderivative. So the derivative of natural log x, like I already said, is 1 over x. And then we do want to keep a dx over here to go along with our du. And then when we find v, that's just going to be the antiderivative of x to the 3/2. So the antiderivative of this, we can find using the power rule. Power rule for integrating or finding the antiderivative just says we're going to keep our x, we're going to raise the power by 1, so 3/2 plus 1 would be 5/2. And then we need to multiply this by the reciprocal of whatever this new power is. So we're going to multiply it by 2/5. So v is going to be 2/5 x to the 5/2 power. Now we take these four pieces here and we can just plug them into this integration by parts formula. So that tells us that this integral is equivalent to u times v, so ln x times all this here, which we'll put as 2/5 x to the 5/2 times natural log x. And then we have minus the integral of v du, so minus the integral of this times this. If we do 1 over x times 2/5 x to the 5/2 times dx, this is actually going to simplify quite nicely because we have a 1 over x here, so this dividing by x over here is going to cancel with some of our x over here. Basically, this is like x to the 1 power. So if we have x to the 5/2 divided by x to the 1, essentially we just have to subtract our powers. So we'll have 5/2 minus 1. So that'll leave us with this canceling out with, or subtracting 1 from our power of x, making it x to the 3/2. So now what we can also do to kind of simplify this integral is we can move this constant out front here. So basically, we can move the 2/5 out to the front of the integral. So we're left with a pretty simple integral, right? Now we've converted this into this down here, 2/5 x to the 5/2 times ln x minus 2/5 times this much simpler integral. So now we still have to find another integral, but it's a lot easier to deal with than this original integral we had. So now if we're trying to find the antiderivative of x to the 3/2, well, we actually already know what that is. We found it right here, right? The antiderivative of x to the 3/2 is 2/5 x to the 5/2. So we can actually replace all of this right here with 2/5 x to the 5/2. So now we can pretty much just simplify our coefficients here. So 2/5 times 2/5 would give us 4/25. So now we just have 2/5 x to the 5/2 times natural log x minus 4/25 x to the 5/2. Notice each of these terms have a 2/5 x to the 5/2 in common. We could factor that out and simplify a bit just to make things a little simpler for us. Doing that, pulling 2/5 x to the 5/2 out here, this term would just be left with natural log x. And this term, if we take a 2/5 out, we're going to be left with 2/5. And then if we take our 5/2 out, this is just going to be factored out, and we're just going to be left with 2/5 x to the 5/2 times natural log x minus 2/5. And then don't forget, whenever you integrate or find an antiderivative, we also need to add our plus c at the end. And that is it. I hope you found this video helpful. If you did, please give it a like and subscribe to the channel. Make sure to hit that bell icon so you'll be notified of any new videos. It's a great way to help support the channel so I can keep making more videos like this for you. Thanks, and see you next time.